NodeJS intermediate class on KodeCamp. And at KodeCamp, we're looking at building a scale economy. So we're trying to prepare you so that you are job ready as at when you are through with this program. So what we're looking at today, it's a very important concept. So those of you joining in, you're welcome, and I hope others will join pretty soon. So once again, I will just, for formalities, introduce myself. I'm Benjamin Ifenyudu, the software developer on the .NET and .NET full stack, and you can always reach me at Slack at AOSoft on the KodeCamp workspace. I also have here with me a mentor, Prosper K, and he is a backend developer experienced with Node.js, MongoDB, Express, and TypeScript. And you can also reach him on the workspace, on the KodeCamp workspace on Slack at prosper.js. So let's get into the business of today. Today, we're going to be looking at a very key concept in programming, okay? So which is object-oriented programming. So what is object-oriented programming? Now, the word object-oriented is a combination of two words, that is object and oriented. Now, the dictionary will describe an object as an article or entity that exists in the real world. So you're looking at entities like a cup, like a human, like a biro, a pen, water. All these are entities, and they can be classified as objects. Now, the word oriented, is talking about a particular kind of a thing or an entity. Okay, so what is it oriented to? So generally, if you put this together in a layman's term, you look at, object-oriented programming as a programming pattern that revolves around an object or an entity. So this object-oriented programming is not what we'll call, we won't look at it as a textbook or standard, okay? It's not specifically documented as a standard, but rather it's a paradigm. It's a way of thinking that has become accepted. So you look at it as basically a philosophy or a methodology that organizes models or software designs around objects. Okay, so it's the focus here is the methodology or the process or the workflow is around objects, and these objects have things that they do. So there are other focuses or methodologies, and let's take, for example, a functional, or let's start with procedural, because languages generally, when began, were more procedural. So let's start with procedural programming, for instance. Now, when we talk of procedural programming, we're talking about procedures. Now, this is, for instance, let's say you want to do something. What could I use as a simplistic example? Okay, so let's say you want to do something very simple, like driving a car out. Now, you would look at the reasonable procedures that you would take into driving a car. So, for example, you'd want to look at, for example, going to the car. So you have the car key. The car key opens the door, and then so you open the door. Probably you want to check all the different components of the car if it's functioning. You want to check the brake fluid. You want to check all those things. So if that is your routine of how you do things, yes. So you go by that process. So you open the car, open the bonnet, check all the different things you want to check, start the engine, check your engine lights, and then once you're good to go, put it in drive and you're off. Now that is a procedure. Okay, so that would be a procedural approach. And if you were to write a code in that nature, you would call it procedural programming. So we have programming languages that are more procedural in approach, and that's C, for example. However, when we come to object-oriented programming, we want to look at this time around, instead of the steps that you would take particularly to solve a problem, you want to look at what are the different entities in this, what are the different entities in order for us to get this done. So one, you consider the car as an entity, you consider the key as an entity, and you would know that, okay, this key has certain attributes or behaviors. So the behavior that the key will have is that the key, the key needs to be turned in to start, or to start the vehicle. Now, you also realize that the key also has a relationship. So while the key is one entity, it also has a relationship with other aspects of the car. Like the key has where it goes into. You put on the ignition, you know that, okay, the car has certain functions, the car can start, so you realize that there could be an approach that is step by step, while there's an approach that first of all defines the different entities that are in and how they relate one, how an object relates with the other to be able to get the task performed. Then we have another type, which is logic programming, and a good language for that is a Prolog. And we have a functional programming, and
the common ones that we have are generally your procedural and object-oriented approach. However, these are other two just for your consumption. So when we talk about object-oriented programming, the question, okay? So an object is a container of values, okay? An object is a container of values combined to form a single data structure that has a particular identity. So let me break it down in okay. Now, when we say a container, you think of it as, okay, this object is a container, and there are certain things that you put
it, okay, so to make it well described as what it does. So an object generally consists of what we could call states and related behaviors. Okay, so states and related behaviors. So this states or data, as you would also call it, can be described as attributes or properties. Attributes or properties, while the behaviors of what it does could be considered the procedures or functionalities. All right, so let's take, for example, have a coffee mug. Okay, so the identity of that coffee mug will be Benjamin's coffee mug because it's mine. Okay, so that's the way it relates, or that's the way it should be described. Benjamin's coffee mug. So that's its identity. Remember, there are different other coffee mugs that exist in the world, but that coffee mug would be mine. So it would be Benjamin's coffee mug as its identity. Then you would then have attributes. So what are the attributes or properties? Okay, what are the attributes or properties of that mug? So one property could be the color. I like the color white for my dishwares. So I'll prefer maybe like white. So the color will be white. Depends on the size. I would like a large size. Then, okay, it depends on the fullness. What do I have in it? Is the mug full of coffee or is it half full? So these are attributes about it. Then when we talk about behavior is talking about, the functionalities or procedures or what it does. So if you want to differentiate between an object, okay, is this, if for instance, you have to contextualize something now, you're asking yourself, is this an object or is this an attribute or is this a behavior? What do you use? So you consider objects as nouns. So you ask yourself, for example, this thing I want to describe now, is it something that can be considered as a noun? For example, things that you can describe using the word D, okay, THA. Let me put my spotlight out. Now, things that you can describe using THA D now, you would consider them as objects. So, for example, the mug. Another example, the book, the pen, the cover, the person, the man. Those will be objects. Now, when you look at attributes, attributes are more of adjectives in a way, okay, descriptive. So they are more of descriptive properties. For example, white, size, fullness, half full. So they are more of descriptive. And when we talk about behaviors, okay, they are more of verbs in terms of actions or what they do. So for example, how does it relate or interact with something else? So it performs something, it does something. And if it doesn't do anything, that is also a behavior. So a behavior could be do nothing. A behavior could be nothing. Okay, so we have that when we are describing an object, every single object has an identity, it has an attribute, and then it also has a behavior. All right. Now, how we look at an object? One of the key things we need to take away from object-oriented programming is that we have objects and we have classes. Okay. Now, a class basically is a blueprint or code template for creating program objects. So when you're talking about the class, you use a class in creating an object. So it is basically the blueprint. If you want to describe, for example, let's say you have, let's say for example, you have a mold for baking bread. Okay, you have a baking pan for baking bread. Now, the pan would be considered as the class because you use it in making the shape of what bread comes out. Okay, so that would be the template. That would be the design by which a new object is created, a new bread mold is created, a new shape of bread or a new specific type of bread is made. So a class is a blueprint or code template for creating program objects. It is a user-defined data type. So users, okay, the user is the one who defines the data type. Now inside the class, we define things as variables, we define constants, we define member functions and other functionalities. And basically, it binds the data functions together into a single unit. So while you might have different types of data and different types of things, it is the class that binds them together and makes it become one entity. So that entity that the class creates is an object. Okay, so classes create objects. Now, just like objects, class components have, these three basic aspects. Okay, so we have the name of the class, which most times we call types. We have the attributes, which are the properties or the data. Then we also have the behavior, which is the operations that it does. Okay, so the operation that it does. So you might not be quite familiar with working with classes on JavaScript. You may also be familiar. But one thing we need to look at here is if you want to consider a class, now you consider a class as the hen that lays the egg. So which one comes first, the hen or the egg? All right, that's been one of the things that has been in debate since, but particularly in programming, the hen comes before the egg. So a class can exist without an object. However, an object cannot exist without a class. Now, you may be familiar with not having to use a class in creating an object, but when we get to practical terms today, I'm going to show you the fact that most programming languages that are object-oriented, they come with predefined classes. So if you are able to do, you're able to create an object, for example, mostly in JavaScript, it doesn't look like you have to use a class to set up an object. That is because there is already embedded in the language a predefined class. Okay, so these predefined classes are what makes it possible for you to be able to create an object. All right, so let's look at this analogy to depict what a class would be. So we have here a dog, and let's call that the dog class. Now, in a dog class, we have certain attributes that are related to a dog. Okay, things that you can pick that dogs should have as attributes or properties or characteristics of the dog. So, for example, you could talk about the species of the breed. Okay, so it's a dog. Is it an Alsatian? Is it a Rottweiler? Is it a Greyhound? Is it Great Dane? What is the breed of the dog? Then you would also consider the size. Is it big? Is it small? Is it very large? Is it very tiny like a poodle, or a chow chow? So those are examples of like attributes, the age, the color. So those attributes mostly are things that you would use in defining, the attributes of the class. The next we have here is the methods, what operations that it does. So a dog basically eats, a dog sleeps, a dog sits, and a dog runs. And all of these attributes are more or less common to all dogs. So when we are talking about a class, we are looking at things that are common to all the subsets. So eat, sleep, sit, and run. And then you would have things that you can relate in terms of property or attributes or adjectives used in describing. So that's what we have to make up a class. So the name, the attribute, and the behavior. Now, we were looking at what then if you have like the basic similarity between a class and object. So what exactly is the difference between a class and an object? So a class is a template for creating objects, while the object, on the other hand, is an instance of a class. So for example, if we were to look at dogs, there is, like a template for how dogs are or how dogs are described in terms of their entity. So you have, the breed, the type, talking about the properties, and then you have the activities the dog does as part of the methods. But when you now have an instance of that dog, you want to ask yourself, okay, this now instance is specific. So this time around, it could be maybe your dog or my dog. So if I have a dog now and I will describe my dog now, I'll be particular about the attributes we can see there in my dog. So one of them is, okay, the breed. So probably maybe a Rottweiler or a Bull Mastiff. Okay, so that would be the breed. Then the size, obviously a large dog. The age can't tell, probably 3, probably lesser. Then the color. So those will then be specific. So when we're talking about an object is talking about an instance or a specific instance of a class. So we'll see that in practical. Another is a class is a logical entity. Okay, so a class is a logical entity. It is a conception. This is you now thinking of the setup. It's more of logical in nature. What are the things that are needed? While an object now, you're looking at an object as a physical entity or an instance. So like now, while a dog or the descriptions or all the things about the dog as an entity would be ubiquitous and it will not be any dog in particular. When we talk about the object now, we'll be specific to this dog and all the different details about that dog. So that's what we mean here. That a class does not allocate memory space when it is created. Okay, now objects allocate memory space when they are created, and we're talking about like memory space on the computer. So when you create an object, it's a variable, it takes a place, and that space it has to allocate that space to it and say, okay, this is a position where this data about this object is stored. But a class does not allocate memory when it is created. Now you declare a class only once. Okay, you can declare a class only once, But in an object, you can create more than one object using a class. So here now we have a class here, and using this class, we can create different objects, as we'll see in the next slide. Now, note that the class can exist without an object. However, an object cannot exist without a class. So let's look at this class on the left hand. So we have here this class on the left hand, the breed, size, age, and color. And from this class, we are having, like 3 objects. So based on this class, we can say we have, 3 objects that can be gotten from here. And here, this is a Neapolitan Mastiff, and the size is large. The age is 5 years, and the color is black. So this is a specific, object. So this is an instance now of this class. Another instance of this class will be the Maltese, and the size small, age 2 years, and the color white. So this could be a person's dog in particular, and this is then an instance of this class. Here now, this is also an instance of this class. And as you see how it is here, you realize that, there can be so many instances of this class. So this class here is more of the template in which, for example, you are going to keep a record of all this. This class will be that template, okay? While this here will be the objects. Now, when talking about objects, one of the things that we need to bring to mind when talking about objects is it's a paradigm, and it's a way of thinking, and it's come to be widely accepted. So it's a widely accepted paradigm, and it operates on 4 basic pillars. For the purposes of this class, we're going to be starting with the first 3 pillars. So here we have the first is abstraction, the next is encapsulation, the third is inheritance, and the last is polymorphism. Now, one of the ways I try to use to remember it is I could say A, E, I, O, and the last one, instead of me taking an O as a O, where I just have it as a P, or I could rename them and say a pi. So you could try that way to remember. So let's start by talking about abstraction. And when we say abstraction, what does abstraction mean? Now, abstraction literally means to perceive an entity in a system or context from a particular perspective, okay? So you are trying to perceive an entity in a system or a context, and you're looking at it from a perspective. So when looking at it from that perspective, we take out all the unnecessary details and only focus on aspects that are necessary to that context or system under consideration. Okay, so abstraction tries to create an entity that is in a particular context. And at that point, you look at what are the things that are unnecessary in describing or in setting as a method. You want to remove all those things out and leave only the things that cut across all the different concerns within the context of what you're looking at it. So we will look at it as a specific example. All right. So let's say, for example, you have a person. Okay. Let's say you have a person now. Now, when I mention the word person, in your mind, you begin to think of a human form. You don't yet know who I'm talking about, but you begin to think of a human form, and then you realize that, yes, okay, every person, what are the things that we can ask or say we want to find out about a person? So you want to look at maybe, okay, the person's name. Everybody has a name. Okay, you want to look at the person's age. Everybody has an age. You want to look at, the person's maybe gender. Okay, so there are only 2 genders to put into. So you could consider, okay, the gender could be male or it could be female. Okay, you want to consider things as address, height, color, and all that. Now, it depends on the context for which you are, creating that class. So let's say, for example, you are thinking about you're thinking about persons in the light of applying for a job. Okay, so persons that applied for this job. Now, one of the common things you want to find out about people who have applied for jobs would be their name for a start, their experience. So you see now that by looking at it in the context of people applying for job, we are considering experience as a necessary aspect. We would not be considering who the person's next of kin as at now as a necessary aspect. So next of kin, even though it could be an information that is related to every person, is not important in this context. If we were talking about just maybe like some other concepts and it's not gender specific, then gender is no longer relevant. So it borders on the concept, and that's why at times abstraction may not always be considered as one of the pillars because it has to do with the logic of the human who is putting the class or the object into consideration. So abstraction, in abstraction, we are trying to decide to solve a specific problem and we want to represent the object, okay? We want to represent the entities that are involved as objects, and we are putting away all the things that are not relevant for that purpose. So it's always about context. The next we look at is encapsulation. Now, when we talk about encapsulation, encapsulation is a mechanism that allows us to bind data and functions of a class into an entity. Okay, so you have data and you have function of the class, and you want to bind them together to make it one entity. So it binds it to one entity, the properties and the methods of functions. And the thing about encapsulation is that it hides internal details. Okay, so it hides internal details. Now, this is to protect data and functions from outside interference and misuse. Now, for you to be in an intermediate level, you obviously have worked with some classes. And we're going to see what encapsulation is like from just this brief description. Now, one of the other things it does is it also provides security, and a class is the best example of encapsulation. So let's look at this. It says here, in other words, the principle or the encapsulation principle allows an object to expose just what is needed to use it, hiding the complexity of its implementation. Okay, so let's look at this example we have here. We have here a company, okay? We have here a company, and the company has a name, Acme Incorporated. It has employees, and here it has a method. Now, this method here, sort employees by name, is a function. Okay, so this method here, it's going to sort the employees by name. But here, whoever is going to use this does not need to know that whoever is going to use this class now or this function now does not need to know the working principles or the algorithms that was used in sorting the employees by name. He does not need to know the type of algorithm that was used. He does not need to know the code that was involved. All the person needs to know is when you use this function, it sorts the employees by name. So let's look at it for instance now, okay? We have done last week's assignment, okay, last week's task using the HTTP module. And the HTTP module is basically a class. Now, when you try to use the HTTP module, you might have seen things like REST or send. If you use, you saw HTTP.create server. You saw things like HTTP.listen and on that, server.listen. And you did not know exactly what was done to make it work. All you knew is you had a documented explanation of probably the code setup, how to set up the code, then the parameters that would be involved, and the expected results that you should get if it works. So that's an example of an encapsulation. So they have created the module with all the working principles of how the HTTP module works. You don't know the details. You don't know the specifics. You don't know all the protocols that have gone into it. However, you are having access to the methods. So you can use the HTTP.create server method to create an instance of the server and automatically tag on the functions you need to do, and all your processes work. So basically what they have done there is they have binded the data and the functions that you need to make it work, and they have only exposed the part that you want to use, which is the create server method. Okay, so in encapsulation, what you are doing here is you are hiding the complexity of the implementation, and you're also exposing just what you need. Okay, just what you want the other person to use or what you want to use, and you're also protecting data and functions from outside interference, particularly in highly data-oriented, object-oriented programming languages like Java and C#. Most of the implementations, you have to create an interface and a connection before you can work on that. But we also have that in JavaScript, although JavaScript is not much object-oriented in programming as compared to other languages like Java and C#. So what are the reasons, or why do we hide, the internal data and complexities? What are the reasons behind? Now, the first reason is because you want to provide a simplified and understandable way to use an object without the need to understand the complexities inside. So, for example, one of the projects I was working on today, I had to set up an algorithm for creating OTPs, and in the process, I wanted to just set up my own personal algorithm for having encryption using Bcrypt. Okay, so what I did was, instead of me doing that function, in the controller or in the place where all the main codes go, I created like another portion there. This was on .NET anyway. So I created another interface there, did my setup for the Bcrypt. So I had one for encrypting, and I had another method for verifying. So those two methods, I put them separately, and when I called them in where I was going to use them, all I just did was I called it in interface. So I just said encryption dot encrypt. So now I'm calling the method that I stored somewhere. So instead of me having to fill that place with all the codes, 6 lines of code that I needed for the encryption method, I just put them somewhere else. And anytime I need them, I just pick it and just say, okay, encrypt. When I need the other method verify, encrypt.verify. So I'm not looking at the complexity. It makes the code cleaner for me to see it. Also, at the same time, it makes it reusable. So the second reason is to simplify change management. Now, changes to the initial sort algorithm does not affect our way to order employees by name. So for instance, if I have a method now, okay, that I've set up for encryption and a method I've set up for verification now, if tomorrow I decide, okay, I don't want to use Bcrypt, I want to use maybe another SHA algorithm to do that, I can change the method just in the folder where the file is for the methods. I don't have to go and start reading through the whole the whole controller module of all I've done. All I just need to do is change it there. So what you do when you do encapsulation is you are simplifying your change management. You don't need to go through the entire work to just make the changes that you want to do. You can just locate, this is the folder where the algorithm is set up. You want to change it there. It does not affect the whole process of the other one, so long as what you have in this one works. So that these two are the main reasons for encapsulation. You want to hide the complexities away. You want to also protect the information there. So you want to protect the data and the functions from outside interference. You don't want others to be able to change, what makes it work. Then the last method we'll be looking at today, although we have four, the last method we'll be looking at today is called inheritance. So when we say inheritance, inheritance allows a newly created class, okay, to acquire the attributes of, the attributes and method of an existing class. So let's consider it this way. Let's say we have a class called person. Now, when we have a class called person, person is a very large word, okay? When we talk of person, one of the, or some of the things that you consider as could be related to all persons here is you'll be looking at person in the sense of name, looking at person in the sense of age, and you can look at persons in other different aspects, but name and age are two that we cut across all. Now, this person is a class, and now we have two classes, for instance, here that we can pick out from, a person. So this class employee can inherit the attributes of a person. An employee can have a name. An employee can have an age. Now, aside the employee having the name and the age, there are certain other attributes that are specific to employees. So these attributes could be defined in different ways. So you could talk about attributes as to when a person was employed. You could talk about attributes as to what position the person is in. You can talk about person's functions. So there we're talking about method, what the person does. You can talk about things as, all the things that are specific to the employee. A customer, on the other hand, even though he is a person or she is a person, does not necessarily have, the other attributes. A customer does not have the attribute of when he was employed in that company. So you see now that while the customer can inherit, customer has some new attributes that are added to it. So for instance, you could talk about maybe the transactional history of the customer with that company. You could talk about maybe the caliber of customer is. So if it's a business that has different levels of customer standards, maybe gold, platinum package and all that, you could have all those as attributes or methods available to the customer. The customer does what could be the customer purchases, buys, the customer does this. So these are attributes that will be considered as part of the customer class. So here you didn't have to go and start saying, okay, now I have to start with name. I have to start with age and everything. You know that you already have a person class that has those basic attributes. So instead of you starting afresh with defining those informations again, you just inherit those properties from the person. Now, the employee, on the other hand, could also be broken into other different classes. So you could have manager classes. So if the business has different managers and then you have a class for which the managers will be defined, then you have your manager class and then you have your developer class. Developers, you could be asking like, okay, what languages does the developer have? Okay, you could talk about the frameworks the developer is familiar with. You could talk about years of experience in specific frameworks, but this information will not be cutting across the managers because the managers on their hands may not even be learned in programming languages. So you see that here, inheritance allows a newly created class to acquire the attributes and methods. So from here, manager has inherited the attributes from employee, employee has inherited the attributes from person. So together here, the manager can call or access certain attributes that are available in person because it is a subclass to this employee class, which is also a subclass to the person class. So the manager can then access some of the attributes that are available in this person. Now, what is the major motivation for OOP. Okay. Now, one of the major motivations for OOP is code reusability. Okay, code reusability. The reason why you can use a module as an HTTP module is because the module has been structured in a way that it has, procedures or functions that it does, which we call methods, and it has certain attributes, and it has been structured in a way that anytime you interact with it, it will produce that same result. So if you give it a certain data set or input, it's expected that it will produce the results that are expected. Okay, so the result that are expected is likely what you would get. So that's the reason why it is reusable. So when you have things like HTTP modules, they are basically classes. They've been set together, so that's why you can download it. That's why it's available. That's why you can set it up. When you go on places like NPM, okay, you go on npm.js, and then you want to tag on some dependencies. The dependencies you're tagging on or installing or adding to your project are basically classes. So these classes now, they have their methods, they have their functional attributes, and you're basically tagging them along to inherit or create an instance of them and use them to do something. So for instance, when you go to your system and you save, for example, const express is equals to express, and you're initiating express, you're basically creating an instance of the express class and all the functionalities that are available to that setup. So if you go now, you have imported the module, and then you now instantiate it by saying const app is equals to express, and that at that point you are saying that you have taken on the functionalities that are available on the express module. So reusability is key, or the major motivation. Now, it also allows programmers to reuse tried, tested, and already debugged code and designs. So when you are downloading an application and you can do things, that's all the function of OOP. So OOP is used in so many different places, in game worlds, in web programming, APIs, and all that. Now, inheritance is also called subclassing, and just like I mentioned, so a class that inherits from another class is called a subclass, while the class from which it is derived is called a superclass. So at this point, we're going to be doing some. Practical. Okay, so we're going to be doing some practical examples of this to further buttress the explanations before we get to the question and answer segment. So what I want to do is I want to share my code space using okay. Variable. So here, let's start by working with an object. Let's start with an object. Now, JavaScript objects. Now, this time we are being specific because now we are in JavaScript. Okay, so we're being specific now. Now, I remember saying that JavaScript is not primarily an object-oriented programming language. As a matter of fact, it's more of a prototype-oriented language. So it looks more like functional, procedural, it's dynamic in nature. So it depends on how you want to set it up. But primarily, it focuses on prototypes, while object programming languages, object-oriented ones would be languages like Java, like .NET, okay, C# rather, okay. So JavaScript objects can be created via the object literal, and in this here, basically, you can create. Let me just use the var keyword for today. So you can create, for instance, an object. So let's say we have an object, and so let me just call this JavaScript object, because JavaScript has what we will say some reserved keywords. Okay, so let me just call this a JavaScript object. Okay, so this here is a way to create JavaScript object, and this is using the literal. Okay, so this is using the literal. So here, if I was to, okay, let me just clear this. All right. So this here is instantiating an empty object. Okay, so this is an empty object. There is nothing here. So if I was to console.log this object, you see here, let me just console.log. Okay, or JavaScript objects. Okay, so let me, what page is this? Java. Okay, all right. So you see here now, this is an object that's empty, it has no content. Okay, now you could also decide to put in contents, for example. So let me say, what would I use to describe? Okay, so let me start with a dog. Okay, so let me start with a dog. So let's say we have a dog as an object, and the dog has a breed. Okay, and the breed is let's say bull mastiff. Okay, bull mastiff, and let's say the age is let's say the age is 5. Okay, so this is an object here, and like I said earlier, the reason why we can do this like this without having to go through the whole process of how other languages set up is because this is a class that is predefined by JavaScript. Okay, so this process is predefined by JavaScript, and here you can see this object here. We have the breed and we have the bull mastiff. Now, as we said, objects are basically, you have key and value pairs, and you could also have functions set in them. So apart from this, here we have an empty. Let's have something that has a function. So let's see. I want to pick this same dog. Okay, so I want to pick this same dog here, and I want to give it okay. Let me break this down so that I can put this on different lines. Okay, so here we have here this here are more of attributes, because here they are basically just key and values. They're basically just describing. Okay, now when we talk about methods, methods are more functions. Okay, so a function could be like let me think of a function now. Okay, okay, let me just put this as doing what. Okay, as a function. Okay, so at this point here now, let me just console.log sleeping. Okay, the dog is sleeping. Okay, so okay, I didn't set. Let me put this down here. All right, let me put this away. Let me comment this out. Okay, so here now, this here, you will see here, from what you see, it is showing you that this is a function. Okay, so while these two here are basically attributes or properties, this here now is a function, and this function could do something. So while in this case, this function is just console login. Okay, so this function is console login doing something. Here, this is basically how an object is. Okay, so another way to use to call an object is to use the new object syntax. So for example, you could instead of you coming through this method like this, you could say, for example, var cart, let me use cart this time, is equals to new, and then you come with object here, and then you specify what you want to be available in the object. Okay, so generally these are like two methods of how you can specify objects. So you can use this method here, which is just explicit. It's called the object literal, or you can use the new object keyword. So if I was to console log, for instance, now this object here now, okay, console log, sorry, let's console log card now. Okay, now you see here I have an empty object, okay, at the end, and I think at this point I'm going to have so many things on this page. Let me just put this away, or let me just comment this out. So, all right, okay. So these are the only two things active here. So here now I have this object. So I've created a new object, okay? I've created a new object, and here I haven't quite given it any details or specifics of what it does, but this is another way that you can create a new object. So one by the string literals, which is this, or the other by using the new object. So here, as you can see, this is a class. So I'm going to be showing you much later what a class is in detail, okay, when we get to the pillars of OOP. So let's look at how we can access properties in an object. So I'm going to leave this here so I could send this to you after the class. You'll be able to get this now. Now, additional properties can be added, okay? Additional properties can be added or accessed in one of two ways. So let me use this card property, for instance. So here we currently have the card property, and as we have console.logged, we see that the card property is empty. It has nothing here. So if we want to use the dot notation, we could decide to tag on. Remember, this is an object. We decide to tag on the var, and let me give it a name. So let me say the cat's name is Milo, because I can't remember any name to pick up now. Okay, so the cat name is Milo. And let me get this cat here. Okay, okay, okay. Let me run this up. Okay. All right. So you see here now that I have gotten the new, a new field. Okay. So something here new has been added to this card, which is a new property, which is the name. So you can use the dot notation to access. Okay. So here I've used it in adding a property, and then you can also use it in accessing properties that already exist. So let's say, for example, we have a new object as a person. So let's say a person. Let me be specific this time around, and let me use more of the new syntax. Let me put this out. Let me put this out, and let me put this as const. Okay, so const, let's say a person. So a person has the following properties. So let's say the person has name, and what could be the name of the person? Let's call the person's name James. Okay, so let's say this could be the first name. Okay, and let me just use this for the last name. So this could be the last name. So James Bond. Okay, that name came out well. This is James Bond, and here you could have a method or an object even in an object. So here now, let me put something specific to James Bond. Okay, so let me say movies. Okay, so in the movies here, what are the movies that he has done? Now, apart from the movies, okay, so let me say movies that he has done now. So apart from the movies that he has done, let me say now that I want to also add, for example, information. Okay, so movies he has done would be maybe, I can't remember any of the movies. Let's say Tomorrow Never Dies, and the year it was made. Okay, so let's say I want to say title now. Okay, so the title of the movie, Tomorrow. Tomorrow. Somebody knows when the movie came. Okay, you could tell me. Because I'm not sure I remember now. So let's say tomorrow. I think tomorrow has one. And tomorrow never dies. Okay, so let me put that as a title. So tomorrow never dies. And the year. Okay. Oh, sorry. The year. I don't know honestly. So I'll just put 2002. Okay. All right. So let's say we have this now as object. What you will see here is I have this information about this person, and while movies on its own here is an object, this object here has been embedded in another object. Okay, so in the object called person. So how do we access it? Now we can access it two ways. One of them is called the dot notation, and the second one is called the bracket notation. So here now, I want to access this using the dot notation for a start. So let's say consider block person. So when you, for this, I want to put, let me use nodemon for this. So I don't have to start this many times. So nodemon JavaScript. All right. Okay, so when I console.log this person, I can see here I have his first name, I have his last name, and the movies that he has done. So here I have the title, okay, Tomorrow Never Dies and the year. And let's say this is one example. I can access this person here now, and I can get his first name using the dot notation by saying person dot, and you see it shows up here. So getting his first name, I see James. I could get his last name. Here's the last name I called it. I called it last name. Get his last name Bond. And then if I want to get the movies, now this movies here, okay, will show me the this movies here is going to show me the object. So from here now, I could decide, okay, what I want to get now is the sorry, please. What I want to get now from it now is the title. Okay, because right now it's just one object, it's not an array. Okay, so when we get to data structures and things, we'll look into difference of array, but generally for start, we are starting with dot notation. And from here, we can see that we can access, an object in an object. If I wanted to get the year, I could go person.movies.year, and I can access that information right here. So an object here, we've been able to combine attributes and even another object into this object. So when we're talking about object-oriented programming, we're looking at being able to, you can nest an object in an object, you can associate it in different ways. So that's the goal. Then let's look at it using bracket notation. So let me take this one down and use bracket notation for the purposes of this. So the name remains the same. The information about person remains the same. So if you were to do object, you were to try to get information in an object, and then you pick out what you are trying to get, the field. Okay, so what is the key? So here, let me put this out so the arrow goes off. Okay, so here, this is the key, and this is the value. Okay, so this is the key and this is the value. So it's good you familiarize yourself with that, because when we go into details, you can see here now, once I go person and I bring out that bracket here, I am left with 3 choices to choose from what is available. So if I go person of first name, I have James and I have his first name. Now, a lot of people are not quite familiar with using this method. They are more familiar with using the dot method. But if I wanted to get the next, maybe like, in movies now, what if I wanted to get in movies? And here I have accessed the movies. Now I want to get a field in the movies, the title. Okay, so this first one here is what helps in getting out the this object, and then from here I'm tagging this along to get more details about the object. if I decide now I want to still further go in and provide further details, okay, I could provide another object and to still be the same process or pattern of accessing the information. So generally, we've looked here at how we could create an object. Okay, we looked here how we could create an object. Okay, because this is not available. Okay, so we looked here at how we could create an object. Here, the object was created here as an empty object, and here now we've added properties to it, and we could access the whole object, or we could decide to use either the dot notation or the bracket notation. Let me put the dot notation up here so it's accessible to you if you want to go through it later. Okay, so here dot movies, okay, dot title. All right. So with this here, you'll be able to access. So this here is the dot notation, and this other here is the bracket notation. When we get further along, we'll be looking at deconstructing, okay, how to deconstruct things from an array, from an object, and things like that. So later on, as we advance in this class, we're going to look at advanced concepts like deconstructions, just to familiarize yourself with that. So generally, this is how objects are created. Okay, so this is generally how objects are created, and you'll see this later on. You'll see this later on in the folder. So you'll see this later on in the folder. So let's go into okay, before we go into pillars of OOP, I want to take a pause to ask if anybody has questions. Okay, do you have a question? Or somebody mentioned Skyfall, that's a different actor. You could actually create a long list. Okay, yes. So let's take questions. Any questions for me before we move into pillars of OOP, and I show you with practical example what that's like. Yes, anybody? Any questions for me? If you have a question, please raise your hand, and we'll call on you so you can unmute your microphone. Okay, no question for now. No question for now. All right, great. If any hands is raised, please let me know. All right, so we want to look at the first concept we looked at today, which is abstraction. We want to look at the first concept we look at today, which is abstraction. So let me share my entire screen so I'll be able to flip between the material and the page in explaining. So okay, this is up. All right. Okay, so the first concept we looked at is abstraction. And we said abstraction, it literally means to perceive an entity, okay, in a system or context from a particular perspective. And we said that, this is based on the perspective or the context to which you want to look at it. So this time around, we want to look at it from a class perspective. Okay, so if we have, we're talking about now creating a class. So let's see how we could create a class for, what was one of those examples we looked at? We looked at a dog. Okay, so we have a dog here. All right, great. So this is a dog. The dog has these properties, and the dog has these methods. Okay, so attributes and methods. So this is the dog class. So we call this the dog class. And okay, so in this dog class, okay. All right. Come on, please. Okay. Now, okay. Sorry. Okay. Now, in this dog class, now we have the dog class, and from here we have certain attributes here: breed, size, age, and color. Okay, breed, size, age, and color. So in classes, we have what we call a constructor, which I'm going to thoroughly explain next week when we look at data structures and that. Or probably I should explain that in the next class. I'll take more time to explain constructor functions, prototypes, and that on our Friday class. So generally, we have a constructor, and what it's basically done is it's a way of injecting, parameters that you want to be available in a class. So if, for example, there is not going to be any, or how would I describe it now, like a parameter that you take in from the user or from the object when you are instantiating the object, then you can have an empty constructor. But if, however, there are going to be parameters or things that you want to receive in, you do that using the constructor. Okay, so it's more like you are injecting the function. So here we want to take the breed, the size, the age, and color from each instance. So I'm going to just put here the breed. Okay, the breed, let me spell that right. Breed, the size, the age, and the color. Okay, now in our next class, we'll look at this pattern I want to show you here. But what we want to do now is we want to be able to access these informations later within this class. So what I'm doing here is I am binding. So what this is doing here is that this is this is trying to bind this entity here to this class so that it will be available in the class. Okay, so the entity that comes in is going to be binded. If you're using more of .NET now, you will call it injection, dependency injection. So you are injecting, or you are making this parameter that is here, you're making it going to be available as a state in this class. Okay, so here we have this .breed. So I also want to tag this on. This size is equal to size. Okay, this age is equal to age, and this color is equal to color. Okay, so these parameters now are available within this class, and I could decide to use this parameter in a way I choose. Now, I could decide to do this by a method that I'll be describing here in the conduct. So if I was describing here in the constructor, I could do something like this as a method, and maybe this dot, should I say describe? Let me say describe. This dot describe. So I want to describe this dog, and it's a function. Okay, so it's a function. So I'm calling on a function, and what should the function do? So the function should, let me just return. Okay, let me return. So this function should return something like, how do I put all this into words? Okay, this is, okay, so I could say this is, then I want to pick the size. Okay, so this is this. I want to pick the size, and then here, while you are in the constructor, you can access the size. Okay, with just the size like that. So I want to pick this. This is the, okay, so this is a size. I don't even know how to put this English together. If I have an English student, okay, this is a large. Okay, so I think large come first, then age. This is a large, so I'll put space. Okay, we could actually have used string literals. Then let me use string literals because this is looking messy to me. So let me use string literals. Okay, so let me use this. This is then let me bring that in now. Okay, so this, what do I want here? I want size. So this is a large age now. This is a large age year old. So I'll put age here. This is a large age year old. Then I'll put color. So let me put color here. Okay. So let me put color, and let me put the breed. Okay, so breed. Okay. All right. So yeah, I'm missing a string. Yeah. All right. So please, if you're not familiar with string literals, let me know so I could explain it better to you. But if you're familiar with this, this goes. All right. So this is a size, age, year. Okay. So let me call this 8-year old. Okay. Okay, so let me put this here. So this here is a function, and this function, what it's going to do is going to describe this dog. So this here is part of this class, and like I mentioned to you, what you have here. Okay, I think I still have something that's running. Okay, so let me use node mon here. Let me use node mon here also. Node mon or pguys. All right. Okay, so currently I have nothing running here, not console or logging anything. So what this is going to do is if this function is accessed, this function is going to return this value using this, okay, using this. So here, this is a dog, okay, and I have created a class now by way of abstraction, picking only the qualities, okay, that are pertinent or important. So I'm not talking about if the dog is injured, so there's no context for it. So things like that are not going to come in. Now, coming over to here now, I want to make an instance of this dog. So an instance of this dog is an object. So the dog here is a class, while an instance of this will be the object. So I'm just going to pick, let me just pick this information from here so I don't have to go type in here and everything. So let me just pick this and paste this here. And I'll comment this out. Okay. All right. So here now, I want to create an instance of this dog here. So I'm going to call this my dog. Okay. So let's say const my dog is equal to, and then I want to access this dog class. Okay. So I'm going to make an instance of this dog class. So generally now, this instance of this dog class, if I was to return this without providing any of the information here, let me show you what's going to show up here. Okay, so you see here, it's saying here that the breed is not defined, but it is how do I put it? It is a dog. Okay, so it's a dog as an object now. Okay, so remember that what I consoled here is not dog. What I consoled here is my dog. And here you are seeing here that you're seeing dog here. So it is saying here, this is of a class of a dog. And in this here, you have the breed, you have the size, the age, the color, and the function described. However, it is not, this information here is not provided. So that's why you're seeing undefined. So here, going by here, I want to pick, the breed as, Neapolitan Mastiff. So I'm going to start with the Neapolitan Mastiff. Now, remember that this should be a string. Okay, so here now, you see I have the information Neapolitan Mastiff here. So the breed now has been explicitly defined based on what I'm picking here from the constructor. So what is the first thing the constructor is asking for? Breed. The next thing it's asking me to provide here is the size. So let me take the size from here. Okay, so this is size, and then I'll see if the English actually came well. Okay, so I want to put the size as large, and okay, so what's the new information I have here? So, okay, so I have size large, okay, and I want to put the information here as okay, age 5. Okay, so let me just put 5, and I want to put the information as the color. So the color here is going to be black. Okay, so let me just put black here, and then you see now I have all the information for the instance. So the breed here is available, the size is available, the age is available, the color is available, and I have made a new object that has using this. So this was used in creating an object. So that's abstraction. So in abstraction, what you are looking at, your key takeaway in abstraction is you're trying to decide to solve a specific problem using an object. So in that, you are trying to define the object using a class. And in the class, you are describing the key things or informations that are necessary. What is unnecessary is not included there. So that's basically the concept of abstraction. Okay. Now, if I was to return, for instance, now what this does in terms of now the function now, I could decide to do the describe, okay, and this is a function. So I could instantiate the function, and you see it here. This is a large 5-year-old black Neapolitan Mastiff. Okay, that English came out right. Okay, so this is a large 5-year-old black Neapolitan Mastiff. Okay, so I can access the method here. Okay, I can access the method if I want, and I can access the properties. Okay, so if it was just a property I want to access, like, okay, my dog, what is the breed of my dog? So I can console.log my dog the breed, and this is a Neapolitan Mastiff. So that's the concept of abstraction. The concept of abstraction is for you to be able to put together your thinking process and what you want to get abstracted into an object. So let me leave describe here for you, so you can see it here in the notes. Okay, now we'll be moving over to the next concept, which is called encapsulation. Okay, so which is called encapsulation, and to do encapsulation, or let's go over the concept and see, okay, the key takeaway from the concept. So encapsulation is a mechanism that allows us to bind data and functions of a class into an entity. Basically, we've seen that, and it binds it into one. Okay, it binds it to one entity, both the data properties, okay, and functions. And the key takeaway is it is hiding the internal details. Okay, so it's hiding internal details, and it protects data and functions from outside interference and misuse. So in this other words, like what we saw here that here they have a function sort employees, sort the employee name, employees by name, and the function does something, but we don't know exactly what the function does, but we know, yes, the function does something. So here, let me think of what I can best use to describe it. Let's just do like let's do a simple, or let's do simple interest, for example. Okay, let's do simple interest. So let's have a class, and this class we'll just call it simple interest. Okay, so we'll just call this class simple interest. And for simple interest, what are the things we will need in simple interest? Okay, so simple interest, principal times rate times time over 100. Okay, so for our constructors, what we will be receiving, okay, so what we'll be receiving by way of our constructors would be, we will be receiving, let me turn this off, okay, so let me clear this and turn this off, okay. Okay, so what we'll be receiving here by way of our constructors now is we'll be receiving things like our principals. So we want to get our principal, okay, we want to get the rates, and we want to get the time, and based on the principal rate and time, we should be able to perform a function. So the first thing we go again, we want to say this dot principal, okay, this dot principal equals to principal, okay. Then we want to say this dot rates equals to rates. We want to say this dot time equals to time, okay. And from here, we have our key takeaway. Okay, so this is our constructor. Now, in this previous class, I had this to describe the function here. I had it binded with this keyword. So I'm going to do this binded with this keyword here. And I'm also going to show you that you don't need to always do it binded with this keyword, but there are key takes away from there. So let's do this dot calculate. Okay, so this dot, let's do this dot interest. Okay, this dot interest. So this dot interest now, let's make it a function. And what this function should do is that this function should return the formula for calculating your simple interest, which would be principal. Okay, so principal times rates times time divided by 100. Okay, so okay, Okay, I used the box bracket. That's why I'm showing me an error there. So let me put this up. Okay, so all right. Okay. All right. So this so this is for us to calculate simple interest. Now we want to instantiate the object now. So let's say I'm an individual and I have okay, I have invested in a business and I want to find out my interest. Okay, so let me take away my interest. My interest now, I'm calling on the new keyword, okay, and I am calling on the class. So the class now is simple interest class, okay. So and I'm instantiating it. Okay, so this here, I have instantiated this object now. So this object here, my interest, is of the class of simple interest. So if, for instance, now I was to console.log or my interest, you see what I'm talking about. So let me go by my interest here. All right. So, or let me just console.log this. Sorry, not in that I should be running this. Let me use node 1. Or I think I run this node 1. Yeah. Okay, so if I run this now, you see, sorry, in the terminal. So you will see here in the terminal that my interest is of the class of simple interest. And here I haven't yet given it the principal rate and the time. So let's say I was doing a business and I have maybe like 100,000. Oh, okay, let's say a million. Okay, 100,000 is pretty small money. Okay, so the principal. So I'm doing this now based on this. Okay, the constructor. So I'm doing this now based on the constructor. So the first thing we're putting here is the principal. The next thing is we're putting in the rate. So let's say the rate is let's say the rate is 13%. Maybe I did maybe this 13% looks like something good for federal government bonds. And then let's say time, okay, time of like 5 years. Okay, so with this here, you see now that I have provided this information here, the principal, the rate, time. And if you look here, you see that the function is here and the function is not made in detail. So you cannot see the information in the function. You cannot see what the function does. So this is what we call hiding, okay? Look at what we said here. We said that it hides the internal details. So if you look at it here, you are seeing here that when I call on this class that I have instantiated here, it picks the information. But when I'm trying to get the interest now, okay, which is part of it, it does not tell me what the formula here is. It just shows me function anonymous. All right. So that is what we were looking at when we talked about hiding the internal details. So wherever I'm using my function now, it's not going to be primarily concerned with how I do my algorithm or what it's done here, but it's going to use it. So now I want to get the interest. So let's say my interest, or maybe I could have called it calculate. So my interest. Now I'm only console-logging it, and it's showing you here that it's a function. So I want to like instantiate the function. So if you see now instantiating the function, it shows me that this is 650. I thought I said a million. Okay, yeah. Just the interest. Okay, so the interest here is 650,000. Okay, 650,000. Now, if I wanted to have another maybe like function, like I was saying here, you can, apart from using this keyword, okay, you can also you can also set a function outside. So I want to call this function what do I call it now? Let me call it total amount. Okay, let me just call this total amount now. Let me just say total amounts or total return. Let me just call it total return now. Okay, so this total return now, I want to make it a function. And what I wanted to do is I wanted to basically return, okay? I wanted to return two things. I wanted to return the principal. Now the challenge is I cannot access principal here, the way I accessed it the other way, I have to use the this keyword because I am outside of the constructor. Okay, and then I want to also get the interest. So I'm going to go with this dot interest. Okay, and it's a method. So I want to go with this dot interest dot method. And let's see if this works. Okay, so let's see if this works. If it doesn't work, we'll just tweak it and see. So here, what do I want to get? I want to get total return. Okay, so total return function. Okay, let me just press enter. And yeah, okay. So you see here now, it has done the calculations here for the interest, and it has done, it has added the principal to it to give me my total return. So I could get my total return from this. So the key takeaway here is this method is available, okay, outside of the constructor. But if I'm out of the constructor, I want to tag what it is I do here using the this keyword. Okay, so let me show you. Let me show you this. Okay, let me show you this now. Let me move this up so you see what I'm talking about. Okay, so I'm moving this up now. This is within the constructor. I want to start by using the this here. Okay, and you see once it works. Okay, I can decide to remove the this in front of the principal, and you see here it works also. Okay, now if I want to do that for the interest, you see it's not going to work because the interest is not defined. So I want to use this keyword to specify this. So these are some of the challenges that you may see later on when you want to use this and everything. So what I'll just do is I'll just return it here to being out of the constructor so that you can have the opportunity of seeing the two methods and everything. So we're already short on time. In our next class, we'll cover inheritance and then polymorphism. So at this point, I would like to take questions. Okay, so at this point, I'd like to take questions. If you have questions, you can raise your hand so we have enough time to answer these questions. Yes. Yes, please. If you have questions, let me know. Okay, Solomon, you can unmute your microphone and ask a question.
Yeah, hello, good evening, everyone.
Yeah, good evening, Solomon.
Sorry, I don't know if I'm always moving forward. Well, probably because I read out of the class though. So my question is from this constructor,
yeah,
there are some other modifications I think which I just want to know the difference. If we do not put in this constructor, we have this parameters principal, comma rate, comma time, and we are also giving this dot principal the same arguments, principal, rate, and time. This keyword. Now my question is, if we omit these three, the argument, can I call this argument of parameters? This principal, rate, and time. If we can omit it and just put this dot principal, this dot rate, and this dot time alone without all this, the one in white actually. So does it work like that as well?
Okay. Let's be. The code is here. It's running. Okay, it's open. So as you're saying, it's something that you have the advantage of like explaining. So you tell me the one you want to be moved out. Let's see. Is it this principal?
Yes,
this one here?
Yes. If this principal is removed and the one we are giving the value like equals to the principal, yeah.
Okay, you want to take this one out, right?
Yes,
and you want to take this one out.
No. This dot principal will still be there. Just that we just remove the one we give it as the value. Yeah, we remove the principal alone.
Okay, you like
yes,
this
exactly.
what I'm talking about.
So I'm saying, will it work this way as well?
Well, you can see you can see it in the code here. What it is saying here is that the principal is not defined. Okay.
Okay.
Okay, the principal is not defined. So basically, what is happening here is you are, by way of this formula now, does not know this value. And it may even mistake this value now for rate, since rate is the first thing that's provided here. Okay. So the purpose of explicitly defining them here is so that when you are sending in these values from here, it knows what value is coming in. So if you look at it now, you see everything is back to running. So that's the purpose of this. So the purpose of this is you want to use this to say, okay, this argument that is coming, this is it. Now, another purpose is that the argument that is coming might not be in this thing. For example, I'm calling this one here principal. Okay, I'm calling this one here principal. What if I called it pre, and here I called it pre? Okay. You see what I'm saying now? So what if I called it pre here and I called it pre? Now, at this point here now, what you want to see is you want to be sure of what exactly is it that you are referring to. Okay. So the purpose is for you to be able to flexibly identify what it is you are describing. So here, so where was I? Okay, so here I called it pre, and here I called it pre. And let me change this to pre first. Okay, so let me change this to pre here. So you see now the point of changing it to pre, you see that it runs, right? Okay. So, but here in this place, this principal is accessing it directly because this one here is not within the constructor. It's only in the constructor that here is explicitly defined. Okay. So that's why you see this one. So this one here is accessing this principal directly from here, while this one here is accessing it directly from this directly from the constructor. Okay, so it's possible that what you might have been familiar with is trying to access it directly as this principal, and you are not using the constructor. You're basically just going straight to this argument. So those arguments now, let me try to take other questions. Okay, so if you have a question, please, I can see 3 hands up. Let me call the name first. Okay, so, all right, so who's the next person? If you've asked a question, someone can lower your hand. Okay, Kelechi, let me take your question so that, Kelechi, let me take your question.
Okay, good evening.
Yeah, good evening.
I just want to clarify the difference between the abstraction concept and the encapsulation, because it has been a problem of mine. Like, I almost see them as the same thing.
Okay. Okay. So if I get your question right, you want me to clarify the difference between what and what now?
Abstraction and encapsulation.
Okay, abstraction and encapsulation. Okay, when we talk about abstraction, abstraction is more of the conceptual phase, when you are conceptualizing what is an object, what is a class. Okay, so abstraction is the point of you defining what the class will contain. So for example here, this here is an abstraction of what a dog should be. A dog should have a breed, a size, an age, and a color, and it should be conceptualized as whatever comes out from this dog will be an object. So here in this place here, where I have initialized a dog, which I would call my dog, I have now given it a breed. Okay, so this here is the abstraction here is what come about in defining what a class should be, and then how the class should create an object. So that's abstraction. Then when you're talking about encapsulation, encapsulation is it's somehow similar to abstraction in the sense that both of them are still binding, the attributes and everything. But the key takeaway in abstraction, like I mentioned here, is we are looking to hide internal workings. So you are looking to hide the internal workings of your methods. So like I showed you here in this place, let me put every other confusing thing off. Okay, so let me put these distractions off. Okay, so here now we have this here. So this is when I have initiated the function, but let me not initiate the function. Let me try to show you what the function is. If I try to show you what the function is, it doesn't show me. It hides it. It says that this is the encapsulation I'm explaining now. Encapsulation says it's hiding its internal workings. So what you are seeing here now is just function, but okay, how is it gotten? What is the algorithm behind it? What is the code or the solution? You don't see it. So that is what abstraction means in object programming, object-oriented programming. I hope that's cleared it up for you.
Okay, yes. So if I'm getting it straight, abstraction is like hiding code, like just making the user not bother about code. While encapsulation is like making them not access it at all.
No. Abstraction is about conceiving an entity in a context. Okay, conceiving an entity in a context. So in abstraction, we are like, I want to create a class of something. What are the expected attributes and methods that this class would have? Okay, so if, for instance, now I talk about cake. Cake is an idea. Now you begin to look into cake and like, okay, what if I was to, for instance, go into cake now, a cake business, or have a website for cakes now? What are the key informations about cake that I would use? Okay, so one of the things I'll look at is maybe in description, I would say, is the cake, does the cake have icing or not? Is the cake a chocolate cake, or is it maybe a vanilla cake, or is it a strawberry cake? So you begin to see I am abstracting, the expected properties, or in the context of
the attribute.
You understand exactly. But when we now talk about encapsulation, encapsulation is, yes, first of all, you are doing the abstraction aspect. But after that, if you have methods, you want to hide the internal workings. So the idea in encapsulation is it is binding functions into the object or the entity. That's one. And when it does that, it is also going to hide the complexity of its implementation. So let's look at this here. What I have done here is I have a class which is called simple interest. This class, simple interest, has this function, this attributes, and has these functionalities. I have hidden these functionalities by way of these methods. Okay, so these methods belong in this class. So while I have inherited or I have gotten the attributes of this simple interest, it doesn't mean that you can see the workings of how this simple interest is calculated. You can also see the workings of how the total return comes in. So if you look here, you just see function anonymous, function total return, but how does it work? It's not showing. So the only thing you can then do is, okay, I'm providing the information, I'm providing, the information here, and based on this information, I want you to, based on this information, I want you to do something. So do your method. Okay, so is that clear?
Okay, yes, very. Thank you very much.
Okay, thank you. Okay, so let's take the last question because already take some time. Should rounding up here. Any further question? Let's take Moscow Tech. Your hand was up before the others. Okay, so today we've.
All right. So good afternoon.
Good evening. Yes.
Yeah. Good evening, Ada. So my question is, I've seen a different way of declaring functions where the function label is removed. Then after the brackets, there's an equal to, then a greater sign. So I want to ask, is there limitations to those kind of use?
Okay, no, there's no limitation. That's basically called an arrow function. Okay, so it's either called an arrow function or a fat arrow function. You're talking about something like let me say do something is equal to or something like this, right?
Exactly.
Okay,
Exactly.
it's called a fat arrow function. There's no limitation to it for a start. However, there's some benefits to it. So when we get to it's a point where we will be teaching data structuring in the third week, the week after this. I'm going to be explaining some of these concepts in details. Okay, so I'll explain them. Then I'm going to talk about things like array destructuring, object destructuring, and explain all this. So because when we get to code, you see them a lot. So I would like to iron them out before we get into week 4 when we'll start, working with the database in NS. All right, so
Thank you.
guys, thank you very much for your time. This is so much question as we could take. This is 8:50, and we should be closing up today so that others will be able to have their own classes streamed live to YouTube. So once again, thanks so much for your time. It's been an exciting moment.
One quick question, please.
Let's see how quick that could be.
Okay, so when declaring what's it called parameters in the constructor functions, can we use things like rest operators, spread operators? Can we use objects or basically iterables there?
Yes. You can use them, but I would like to teach that in detail. Okay, how to use them. I'd like to teach that in detail. So when we get to that point, I'm going to teach that in detail because there are some points where they will be needed. As a matter of fact, if you are working with things like React, you barely can do much without knowing how to use spread operators and that's in constructors. So yes, I'm going to explain them in details. So when we get to that point, you should be able to see that. Okay, so this is so far as we can go. We've already spent too much time today, and I actually hope you are enjoying these classes. I hope you are learning something. And let me call on our mentor to give the closing remarks. So Prosper, could you give the closing remarks so quickly wrap up this class?
Yeah. Good evening, everybody. I've not said anything since. Yeah, well, as usual, thanks for your time, and I hope you had an interesting session. I can say I did. Yeah. It's been exciting and it's been informative. I just hope you enjoyed it as much as I did. So yeah, one thing I want to point out is today we were late to class. Right? We should try as much as possible to make sure we were here early. Classes start by 7 o'clock. We should be here like say 6:50 or at most 7. We should be here already, so we don't have to start waiting for you guys, right? So yeah, we spent so much time. Yeah, and we'll review your assignments and get back to you on your performance. So yeah, thanks again for your time. Yeah, we'll be here on Friday to continue our exciting journey.
Okay, so once again, thank you very much. Please be prompt. We keep to time. As a matter of fact, we are in 10 minutes before the end of 10 minutes before time. We come in as early as 10 minutes to 7. Okay, so please be on time so we can start the class in earnest and cover all the things we need to cover. So that'll be all for today. Any further questions, you could drop them in on Slack channel. So ciao for now. You can log off. All right. Mr. Ike, if you are on the call, you could end the class. We're through for today.
I don't think it is. Maybe we should just all leave.
Okay, so let's all leave. Okay, let's all leave so others can be able to have their meetings. Okay, let's all leave, and then once we're all done leaving, I'll close the meeting.